Hello, now we are going to look at the area of a parallelogram. So a parallelogram is where we have our four-sided shapes and we have two of the sides are going to be parallel to each other. So parallelogram has parallel sides. So we have these two sides here are parallel to each other. They are going in the same direction. If we were looking at them mathematically, we would say they had the same slope. And the other two sides are also parallel to each other. And as a consequence of that, we can say that the length of this side is the same as the length of this side. So the parallel sides are the same size, and the length of this side must be the same as the length of that side. So our dashes here, single dashes here, mean they're the same length, and double dashes here means these two are the same length, and parallel and parallel. So that's what we mean by a parallelogram. And in a parallelogram, we are going to be dealing with the base and the height. So that might ring a bell with triangles that we already know about the area of. So the triangle has our half the base by the height. Well, a parallelogram has the formula of the area is equal to the base times the height. So we don't have to half it this time. So we might think about why that would be. And we're going to look at an argument or two arguments for or where this formula comes from in a minute. So the area of a parallelogram is the base multiplied by the height. And just like a triangle, we need to be careful about what we mean by this height. So if we start at a particular side and we take it as our base, then the distance to the far side, the other parallel side, is going to be the height. So the perpendicular distance, the right angle distance from our base up to the other parallel side is going to be the height. Now, there's a visual argument here for where this formula is coming from. Just to point out to you, if we had the base down here, then our height would be working out this way as well. So you can see sometimes we have to shift things around. We'll start off by giving the visual argument that might be easiest to follow. If we start out with a parallelogram, this one here, and it has a base, which I've put on the top for reasons that will become obvious in a moment, and its height to its far parallel side. If I take the triangle on the end of my parallelogram and shift it over to where I have my triangle for my height listed in, I can see that that overlaps perfectly, and I'm left with a rectangle that has a length of b and a width of h. So the area of this rectangle is the same as the area of the parallelogram, and it's going to be the length by the width, which is just base by height. So that's one way that you can argue for your area formula for a parallelogram. The other one is to notice that if you draw a diagonal up through the middle of your parallelogram, you draw a diagonal there, you see that you have two triangles, and you can work out that these two triangles are identical to the same triangle, just rotated around or reflected. And they both have a base of the base here, and they both have a height here. So we have half the base times the perpendicular height plus half the base times the perpendicular height. Well, that's just going to be a half plus a half is a whole. So that's another way of arguing that the area must just be the base by the height, because it's effectively two triangles added together. But that's enough intro to our idea. Let's put this formula into practice. Area is equal to base times height. So here I'd be looking for the area. So if I want to know the area, how am I going to do it? Well, we do what we always do with our geometry. We're going to say, what shape have I got? I've got a parallelogram. So I'm going to write down my formula for the area of a parallelogram, and I'll fill in any of the lengths that I know. So I know that this length must be the same as up here, so that must be 12 centimeters. And I don't have an equivalent length here. I know that length there would be 4 centimeters, but it's not one of the sides. So that's all I can fill in right now. So at that point, what am I able to say? Well, I know a base, and I know the perpendicular height from that base to the far side, the far parallel side. So I can say my base is equal to 12 centimeters. my height from that base is 4 centimeters, and I want to know the area. And I know my formula, I've written it down. So the area is equal to the base times the height. So I end up with 48, and its area, so that's centimeters squared. So I write down my formula, I fill in anything I can on my diagram, I write down all the information I've got, and I sub into the formula. And if we do that from day one, then we're able to do the questions when they get much harder. So here I'm looking for the height this time. And I can see from context, that should be meters squared. I can see from context that because this is my 15 meters squared means that must be the area. So I've got a parallelogram, and I've got something to do with its area, and I'm asked to find a height. So I'm going to write down my relevant formula. The base times the height. And I know that my area is equal to 15 meters squared, and I know that I have a side here, and I want to find the height from that side. So that means that 3 meters would be my base. It's the base that I have information about, and I want to go up a particular height from that base. So that's what I'm looking for. So H is what I am looking for. So I've listed my formula. I've figured out what shape I've got. Is there any information I can fill in? Well, I know that this length here must be 3 meters as well. So at this point, I can write down the area is equal to BH. So 15 is equal to the base times the height that I'm looking for. So 3H is equal to 15. And I know from rearranging my formula that I divide both sides by 3, because 3 divided by 3 is 1, and I want to know what 1H is. So therefore, H is equal to 5, and the units for that must be meters. Now, in this question, we have to really start thinking about what information we've been given. So I'm asked to find y, and I can see y here is the height from this base. So how am I going to find that? Well, let's look at the information that we've got. I can see I've got a parallelogram. So first of all, I know that I can talk about the area of this being the base times the height. I'm pretty confident that this is going to come up because I've got a parallelogram. And what do I know? Well, I know that this side is parallel to the side that I want for the base, and I know that that means that this base must also be 10 meters. So the base I am looking for is going to be 10 meters if my height is equal to y meters. But I don't know the area. So I don't know the area. If I knew the area, if I was given the area like I was here, I'd be able to find y. But I don't know the area. So how can I find it? Well, I look to the other information that's given to me in the question, because there's more numbers given to me here. And I can see if I have a base of 5, if I took 5 meters as being my base, then the perpendicular height to the opposite parallel side would be 8 meters. So I can use that to find the area of the parallelogram, and then come back to this information once I know the area to find out the value of y. So by laying out my information, by saying, well, this is the formula, this is what I want to find, okay, this is the bit that I'm missing, I can then go back and say, well, how can I find that missing piece? So we need to find this area first. The area, so this is, we're dropping this for a minute and we'll come back to that information. So our area is what we're looking for, and my base now is 5 meters, and my height is going to be 8 meters from that base. So I know that the area is equal to 5 by 8 is going to be 40. So I know that the area of this parallelogram is 40 meters squared. So now can I use that to make progress with my original question in finding y? Well, I now know that the area of the shape I'm looking for is 40. So that means that area is equal to base times height. So 40 is equal to, the base is 10. The height I'm looking for is called y. So 40 is equal to 10y. I can divide both sides by 10 because 10 divided by 10 is going to give me 1. And I want to know what 1y is. So 4 meters is equal to y. So by laying out the information that I'm given, writing down the relevant formula, saying, well, I recognize this shape. I filled in any sides that I could see. Oh, I actually missed one. I could put that in as being 5. So I fill in all of the sides that I can, and then I am able to work out what I know. And then when I hit a roadblock, I was able to say, well, is there any way I can find this missing piece of information? Because I laid out what I was looking for carefully, because I wrote down my formulas and because I tried to sub in, I was able to see how to make progress, even though there were multiple steps to this version of the question. So this is the skill we need to be developing, as well as getting more used to the formulas and shapes involved. This setup of what shape have I got? What do I recognize? What formula can I write down? What information have I got? Can I fill in anything in the diagram? And I keep rolling through it that way. And that's how we build up to success in geometry.